Our objective for today, I can represent data on dot plots and compute standard deviation. Now, last week, we did a couple of practices with standard deviation. Is that correct? Do we need to do another practice? Well, I think we got it. I'm just going to review the example so you guys can see exactly what went into the practice standard deviation. But for today, we are going to move forward and look at dot plots. Okay? Just to let you know ahead of time, today will be probably the easiest lesson of the second semester. So it's going to go pretty fast, so everybody go like this. Bear with me. Here we go. So dot plots. What are dot plots? Here we go. On your prayer model. A dot plot is a data representation that uses a number line and X's, dots, or other symbols to show frequency. Once again, a dot plot is a data representation that uses a number line, X's, dots, or other symbols to show frequency. Example. Here we go. I remember these from last year, Mr. Q. Yes. Here's an example using a number line. They're representing data, and it's showing the frequency for each of those. And this one is titled Salary in Thousands of Dollars. So copy that, and then I'll elaborate a little bit more into that. All right, here it goes. It says dot plot. It's a data representation that uses a number line. So let's look at the example. Are they using a number line? Yes. Are they representing data? What kind of data? Salary in thousands of dollars. Okay. And they use X's, dots, or other symbols to show frequency. Are they showing frequency for each of the salaries? Yes. It shows how many people or how many, how many people earn those thousands of dollars. So there it is. Fairly simple. So if I was to ask you a question from this example, such as, look at it. Tell your neighbor which salary has the most frequency. Tell your neighbor which salary has the most frequency. All right, let's see. Which one has the most frequency? Julian. 35 and 40. Hands if you agree with 35 and 40. That is incorrect. About 35,000 and 40,000. Once again, remember, because I am going to give you some on the pop parte, maybe not today, or maybe tomorrow. I don't know. Anyways, however, the question would be, which one has the most frequency? And if it's titled Salary in Thousands of Dollars, guess what I want the answer in? Thousands of dollars. So which one has the most frequency? $35,000 and $40,000. Does that make sense? Yes, Mr. Q. All right, let me show you a non-example. Non-example. Copy this. No, this one. It's a graph for the domain. We have 0, 1, 2, 3, and 4. And it's labeled grading period. For the range, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it's labeled number of A's. And it's got 4 points on the graph. This is a non-example. Copy that. As you're copying it down, start thinking, this is not a dot plot because, don't say it out loud to yourself. We'll have discussion with it. Copy that. All right, share with your neighbor. Tell them why this is not a dot plot. All right, let's see. Why is this not a dot plot, Esmeralda? It's not on the number line. This is actually a quadrant or a coordinate plane. Does everybody see that? Yeah? All right. So if you were to send this out on your Instagram or Snap it, whatever, hashtag that, please. Say neighbor hashtag, please. All right, Luca, hashtag what? Number line. Pass someone? Charlie? Hashtag what? Dots. Okay. Pass someone? Isaac? No quadrant. You're going to pass it to me? Oh, no quadrant, Mr. Q. Hashtag what, Brody? Look at the definition. See what would be an essential hashtag for that. Another one word. Frequency. Damn. From the corner. Last one, yeah. Isaac, last one. Other symbols. That is correct. Yes. No, I think that's enough. Okay, Julian, go. Hit us with a hashtag. Youth.candy. All right, thank you. All right, let's, before I move on, guys, look up, please. Your book also gives us another type of representation of data. Remember last week we covered bell curves, remember that, with a standard deviation, right? We also covered best fit lines. Remember we plotted points. We fit a line and came up with an equation, stuff like that. But the book's also going to mention stuff that looks like this. Look up, please. If I was to give you data that requires two different lines, such as this one, which means a quadrant, another way of representing data, they call it a histogram. And instead of plotting points like this, they would plot the point. They would plot the point here, but instead of leaving it like this, they would do this. Let's see if you recognize this. Who's seen that before? Yeah, that's what we call histograms. When they do the bar, some of you call it a bar graph, but they also call it histograms. What do they call it? That's another type of representation. We're not going to cover that today, and I don't think we need to address it in regards to just making boxes like that. We can actually just use dots and then, points, and then get our best fit line from there. But I'm just showing you another way of representing data. All right. But today we're focusing on dot plots. Yes. All right. Let's go to example. Oh, let me recap on standard deviation. Here we go. So standard deviation. Last week I said to get standard deviation, the first thing we do is write all the data from least to greatest. Is that correct? Once we write the data from least to greatest on the first column, what do we find at the end? The mean, also known as what? Chi. Remember that? Yeah? Yeah. Okay, so we find the mean first of all the data. Next, on the next column, we take the data, all of the numbers, 1 minus whatever the mean is, all the way through. All those numbers all the way through like this and like this. And the difference for each one, we square them. Is that correct? And we come up with new numbers here. So what do we do with all those numbers? What we do with all those numbers, we find chi again, but instead of calling it chi or mean, they call that standard deviation squared. You guys remember that? All right, but is that what we're looking at for at the end? No, they're asking us to find what? Standard deviation. So how do we find standard deviation from here? Taking square root on both sides, and that's how we get our standard deviation. Yes? All right. And on the graph will be easy to represent because pretty much it would be something like this. It would be a bell curve. We know that the highest point on the bell curve is the mean, or also known as what? Chi. And then first deviation is plus, minus to each side. Whatever we get, we add or subtract. Then the second deviation, and then the third deviation. Yes? All right. So we don't need to do any of those. We already did plenty of practice of those last week. Let's move on to this one. Example 2A. Copy that, please. It says, an ice cream truck offers items at 5 different prices. Mr. Q counted how many items were offered at each price one day. Make a dot plot of the data. The prices for the ice cream truck, that what they offer are anywhere from $1, $1.50, $2, $2.50, and $3. $1 items, I noticed that there were 5 of them. $1.50 items, there were like 3 of them. $2 items, there were 6 of them. $2.50, 4 of them. $3 items, there were only 2. And the number line, if you notice down here, I want you to make that and space it out or scale it by 10 cents. So go 0.10, 0.20, 0.30, 0.40, 0.50, 0.60, 0.70, 0.80, 0.90, and this is $1. 0.10, 0.20, 0.30, 0.40, 0.50, 0.60, 70, 0.80, 0.90, $2, 0.10, 0.20, 0.30, 0.40, 0.50, 0.60, 0.70, 0.80, 0.90, $3. All right, here we go. How many items are $1? 5. So to get my dot plot going, what can I use to represent that? Dots, what else? X's or other symbols. I'm going to draw a Pokemon. Let's see. 1, 2, it's a Pikachu. 3, 4, 5. Thank you. Now, why am I using this symbol? Because I'm trying to make a point that you can use any symbol as your markers. Does that make sense? What's the next item? $1.50. How many items? 3. $1.50 is right here. 1, 2, 3. $2. That's 6 items. 1, 2, 3, 4, 5, 6. $2.50 is 4 items. 1, 2, 3, 4. And $3 is 2 items. 1, 2. Did I create a dot plot? Yes. Could I answer that question? What can I conclude from this data? Tell your neighbor, what can we conclude? Luca. All right. Luca says $2 items are most common. Yeah, I'll take that. How about, can we generalize it to 2 different ones? How about 2 and 1? $2 and $1 items are the ones that they sell the most, or whatever the case. Yes? Show me your experience. How comfortable you are with the dot plots. Yeah, we got this, yeah? So our home plate for tonight. Not Fortnite. Page, hold on. 445. 445. All only. There is tutoring. If I don't see you guys tomorrow, enjoy your home plate. Bye.